Good morning. Today we are going to conduct an experiment on two-stage reciprocating air compressor. We are going to do the performance characteristics of this reciprocating air compressor. First we need to know what is meant by air compressor. Air compressor is a work absorbing machine which will used to increase the available pressure to required pressure. So normally the pressure, the air is available at atmospheric pressure of 1.0315 bar. For our elevating pressures, and then this pressure energy is needed for the pneumatic applications and all those things. So we need to use an air compressor to improve the air, right? To improving the pressure of the air. So this can be, you can see this experiment in inflation stations, and then petrol pumps in variety of applications. It has in machine shop, right? So all those places wherever the higher pressure is needed, we need to operate an air compressor. If you also see in this air compressor for water pumping in the agriculture land too. Okay, so in this air compressor there are different categories are there. Centrifugal compressor. This is a reciprocating compressor because the piston is moving in the reciprocal motion. So this is single stage, two stage, three stage and multi-stage compressors are available for required pressures. Okay, so in our laboratory we will going to take a reading on two-stage reciprocating air compressor. With this, I will give the introduction about the construction of the air compressor. Here you can see this is a storage tank of air. The high pressure has produced and then it will be stored here. Then you can see this is a low pressure cylinder and this is an intercooler and this is a high pressure cylinder. Okay, this high pressure cylinder is supply the air to the storage tank. So this is an work absorbing machine. We need to give a electrical energy or mechanical energy with the other source. So the electrical motor is attached in the air compressor. If we switch on this motor, the motor will start rotating. Then this compressor is connected through the pulley. Compressor is connected through the pulley with the electrical motor. So for cooling purpose, the fan is provided here, right? So coming to this, the piston cylinder is inside this compressor. Okay, so if we switch on this, first the air is taken from atmosphere. So we need to measure how much amount of air is taken to the compressor, so that the air tank is provided at the bottom with orifice. So with the orifice, the air tank is provided. With this orifice, we can find out how much amount of air is coming into the air compressor. So this orifice is directly connected, this air tank is directly connected to the U-tube manometer. With the changes in its pressure head, we can find out the air. And then the temperature of atmospheric air, the temperature of atmospheric air can taken from this thermocouple, and then temperature of air after first stage of compression will be taken from this thermocouple, and then temperature of air after passing through the intercooler is taken from this thermocouple, and temperature of the air at the exit will be taken from this thermocouple. Okay, so these thermocouples are attached in this thermistor. We can change this thermistor value. We can find out the different temperature. Okay, so the energy meter reading has to be taken from this energy meter, and then the pressure levels has to be monitored from this pressure gauges. Okay, so now start this experiment. Starts running, we need to mention that gauge pressure. So this is a gauge pressure and this is an absolute pressure. gauge pressure, absolute pressure, time taken from energy meter and manometer reading, speed of the air compressor, and then LP cylinder, the inlet and outlet temperatures. Okay, will be taken here. So now the gauge pressure is taken from this tank. So the tank is if you see here, the pressure is increasing because the tank is completely in the closed condition. We need to take different readings at different available pressure. So this is the maximum limit of pressure. So we need to operate this compressor within this safe zone. Okay. So with these gauge pressures, we need to note the RPM. The RPM will be taken from this pulley with the help of a tachometer. With the help of a tachometer, we will going to take a speed, and for the different pressures. The time taken will be taken for different gauge pressure and absolute pressure. So the total pressure is absolute pressure plus gauge pressure. So the time taken for the energy meter will be taken from the help of tacho. With the help of the stopwatch, we can take in the time taken.